alpha, yes. All right, so let's see, 12, 12, 12, 12. All right, so let's look at 12. So let me share my screen. All right, so if you look at 12, well, if you look at the problem setup, they first tell me the mean is equal to 12. They tell me standard deviation is equal to 2. If you look at number 12, it says pretty much find the probability to the right of x equal to 10.02. So it's saying to the right of x is equal to 10.02. And if you look right here, it says a normal distribution curve. So a normal distribution curve telling me we're going to use the normal distribution. So let me transition over to my notes. All right. So if you look at this one, we're going to draw this out. Let's draw this out. So if you look at it, it says mu is equal to 12. If you look at it, it's telling x is equal to 10.02. And it's saying to the right. So to the right means this side. So for this one, what you kind of have to remember to do, for this one, since they're asking us to find the probability, you want to use the normal distribution. So, and this one, what you want to do, you want to do it in class calc. So on class calc, you first have to give it the mean and the standard deviation. So for the mean, you're gonna say the mean is equal to 12. And then you can tell the standard deviation is equal to 2. And then if you remember on class calc, then you're gonna press CDF. And then what you have to do, you have to enter the lower bound. And you have to enter the upper bound. So for the lower bound is the lowest part that gets shaded. So the lowest part that gets shaded is that value over there. So it's 2.02. So for the lower bound, we're going to put 10.02. If you look at the upper bound, the highest value that gets shaded, which is here. So that's infinity. But if you're using a TI-84, you want to use 10 to the 10th power. Any questions so far for that? Okay, so what I'm going to go ahead and do, I'm going to go ahead and get the answer of this by using class calc. Then I'll also do the TI-84 and so on and so forth. So we'll go right here, class calc. All right, so in class calc, you go stats, you go to distribution, you go to normal distribution. So if you remember, we say mean is equal to 12, standard deviation is equal to 2. Then what you want to go ahead and do, select the CDF, we could do this. And for the lower bound, we said it was 10.02. 0.02. And for the upper bound, we said it was positive infinity. So for that one, you get the answer. If you look at my screen, it says 0.8389. So say 0.8389. So that's how likely that event is of occurring. Any question on how to do it on class calc? All right, so up next I'm gonna show you how to deal with the TI-84. So for the TI-84, you go to new share, you go to Wabbitoo, you go to share. So if you're doing this on a TI-84, what you wanna do, you wanna hit the second button, you wanna hit bars, and if you look at the second one, it says normal CDF, so you select that one. For the lower bound, we said it was 10.02. For the upper bound, we said is 10 to the 10 power. For mu, we say that is 12. Sigma is 2. You go to paste, you go to enter, and you get exactly the same answer that you get for class calc. And that's how you do it for the TI-84. And that's it for that problem. Any question in regard to that last problem? Cool. All right, so what other question you want me to go over? All right, so number 3. What is number 3? For number 3, you can just skip variance. We never went over variance, so just skip it. All right, so 27. 27, 27. All right. So let's do 27. So 27 says assume that the weight of all packets of a certain brand of cookie are normally distributed. So once again, normally distributed with a mean of 32 ounces and a standard deviation of 0.3 ounces. So you do want to kind of write that down. So it's telling you mean is 32 ounces and it's telling you sigma is equal to 0.3 ounces. So it says determine the probability that the mean weight of a random sample of 20 packets of this brand of cookie will be. So if you look at it, it's a random sample of 20 packets. So they're telling us n is equal to 20. All right. So we want to do 27. So we want to find the probability that a random sample of 20 packages of this brand of cookie will be at most 30 ounces. So we'll put 27 right here. So it says at most 30 ounces. All right. So let me go ahead and transition over to my notes. All right. So if you look at it, that's what I have for my notes. We have mu equal to 32. We have sigma equal to 0.3. We have n is equal to 20. And for number 27, we want to find the probability at most 30 ounces. So if you look at this one thing that you should notice, they gave us a sample size of 20. So since they gave us a sample size of 20, you want to find what mu of x bar is, and you also want to find what sigma of x bar was. So kind of like the question I gave you on the test. Mu of x bar is equal to mu. So that's 32. But sigma of x bar is equal to sigma divided by square root of n, which is 0.3 divided by square root of 20. So let me go ahead and work that out on my calculator. So we'll say 0.3 divided by square root of 20. And you get 0.067. So in your calculator, when it asks you for mu and sigma, for mu, you're still going to put 32. But for sigma, you have to put 0.067. If you don't put 0.067, it will give you the wrong answer. All right, so let's go ahead and draw this out. So 32 goes here. And then 30 will go over here. So if you look at the word at most, so if you look at the word at most means that that should be the highest number, but it could be actually smaller than that. So when I said at most, it means 30 is the biggest number, but it could be smaller than 30. So you shade the left-hand side. All right. So for this one, once again, we're gonna go ahead and we're gonna do class calc. We're gonna say a normal distribution. We could say mu is equal to 32. Sigma is equal to 0.067. Then what you want to do for this one, since we want to find the probability, you want to select CDF. And then for the CDF, it's going to ask you for the lower bound and for the upper bound. For the lower bound, if you look at it, so you keep on going and going to the left-hand side, that's technically going to negative infinity. If you're using the TI-83, you want to put negative 10 to the 10 power. If you look at the upper bound is essentially cut off at 30. So for this one, you do 30. All right. Any questions so far? I got normal distribution 32, 0.067, CDF negative infinity all the way to positive 30. All right, so what I'm going to go ahead and do, transition over to class calc. So go to class calc. Let me erase this. So on class calc, you want to go to stats, you want to go distribution, and you want to do a normal distribution. So for the normal distribution, you put mu. Mu is equal to 32. Sigma is equal to 0.067. You want to select CDF. And for the lower bound, it's negative infinity, so that's perfectly fine. But if you look at the upper bound has to be 30, so let's change that to 30. Right. So if you look at this drawing, it says that this is equal to 0. So for this one, you put 0. And that's your final answer for that one. So the final answer for number 27 should be 0. No. You're never, ever, ever going to use PDF you're always going to use CDF. CDF is always when you're finding the range between two values. Because we never have used PDF, so for normal distribution, you're never going to use PDF. All right. Any other question in regard to the practice exam? All right, 29. All right, so let's look at 29, 29, 29. All right, so let's see this one. All right, so if you look at this problem, they tell us they have 100 people. So let me write down they have 100 people. If you look at it, it said 26 of the people reported a rise in blood pressure. So we'll say 20, the 26 people rise in blood pressure. The next thing they give us is tell us 18 reported loss of sleep. And then they tell us, and 12 reported both of these side effects. So 12 reported both of the side effects. All right. So if you look at number 29, 29 is asking will experience loss of sleep. So 29 will experience loss of sleep given a reported rise in blood pressure. All right, so let me switch over to my notes. All right, so this is so far what I have. I have 100 people. 26 have rise in blood pressure. 18 report loss of sleep. 12 reported both of these side effects. And 29 is asking will experience loss of sleep given a reported loss, a reported rise of blood pressure. So right here is the given. So the given is important because this is information that's given to us. So this is information that we already know has happened. So pretty much for this one, I'm gonna say loss of sleep. I'm gonna just label this as L. I'm gonna say rise of blood pressure. I'm gonna label this as R. So for this one, we want to find the probability they have loss of sleep, given that they have a rise of blood pressure. So for this one, what you want to go ahead and do, you want to go ahead and find the probability of L and R, and you divide that by the probability of R. So that's just going back to the formula of the conditional probability. So any questions so far for that labeling? All right, so let's go ahead and find the top. So if you look at the top, it says find the probability of loss of sleep and rise of blood pressure. So these are people who are suffering from both side effects. So if you look at my labeling, I put 12 reported both of these side effects. So that means you put 12 out of 100. And then if you look at the bottom is probably they have a rise in blood pressure. So a rise of blood pressure, if you look at the very first or the second line I put 26 have a rise in blood pressure. So you put 26 out of 100. So for any question, I got 12 divided by 100 and 26 divided by 100. Wait. All right. So what you want to go ahead and do, you're going to want to go ahead and get rid of the fraction. So to get rid of this fraction, you multiply by the reciprocal. The reciprocal is 100 divided by 26. 100 divided by 26. This 100 and this 100 cancel. This 26 cancel. This 100 and this 100 cancel. So pretty much you're only left with the 12 and the 26. So if you do 12 divided by 26, you get 0.4615. And that'll be it for the last problem. Any
Wait,
questions?
so you wouldn't just leave it on the top? Because didn't you just cancel all the bottoms, so the bottom would just be, wouldn't it just be like 0 or something?
Well, no, the bottom will be 1.
Mm-hmm.
So the bottom will
So
be
this
1.
12 over 26 is just of the top one, right?
Correct.
Oh, okay.
Yeah. All right. So that's it for 29. Any question in regards to 29? All right, lastly, let's do 30. So let me switch over to the practice exam. Let's do 30. So if you look at 30, it said will experience neither of these two side effects. So that means we don't want them to suffer from blood pressure or sorry, rise of blood pressure or loss of sleep. So we want them to suffer from neither. So let me write that down in my notes. So 30 will experience all right, so let's go ahead and do 30. So for 30, it said will experience neither of the two side effects. So for this one, well, if you actually look at the problem, well, for this one, the easiest way, because we want them to experience neither of the two side effects. So we don't want them to experience loss of sleep, but we also don't want them to experience rise of blood pressure. So for this one, what you want to do, I'm going to find the probability. So we're going to find the probability they experience loss of sleep or rise of blood pressure. And then all I'm going to do, I'm going to just take the complement of that. Because pretty much we want people who suffer from neither of these two side effects. So what we have to do, we have to find the probability that they do suffer from one or two of these side effects, and then just essentially do the complement rule of it. So for this one, we're going to find the probability they suffer from loss of sleep, added to the probability they suffer from rise of blood pressure, and subtracted by the probability they suffer from loss of sleep and rise of blood pressure. So for this one, we have to see how many people suffer from loss of sleep. So if you look at it, that's 18. So we say 18 out of 100, plus we want to focus on people who suffer from rise of blood pressure. Rise of blood pressure will be the 26. There you go, 26 out of 100. And then you subtract it by the people who suffer from both of these side effects. So that's 12 out of 100. All right. So if you do this, you get 32 over 100. If my math is correct. So that means this is 0.32. So this is the probability that somebody suffer from either loss of sleep or rise blood pressure. But the thing is, we want them to suffer from neither of these. So to find the probability that they suffer from neither of these, you do 1 minus 32, and that will give you 0.68 or 68%. And that's your answer for that one. Any question in regard to that last problem? All right, so which other question do you want me to go over? Let's do 31. Only one. So for this instead, we'll experience only one of the given side effect. Cool. All right, so for number 31, you kind of want to just focus and use a Venn diagram for this one. So for 31, it says we'll experience only one of the given side effects. So that means we want people who only experience one of the side effects. So we want to focus on people who either got loss of sleep or they got a rise blood pressure. But we don't want people who have both of these side effects. So let me go ahead and transition over to my notes. So for this one, we're actually going to just use a Venn diagram. Okay. So for the Venn diagram, so this is for people who suffer from loss of sleep. These are people who suffer from a rise blood pressure. The first thing you want to go ahead and do is put how many people are in the middle. So that would be 12. So you put 12 in the middle. Because those are people who suffer from both loss of sleep and pretty much high blood pressure. So if you look at it, we have 18 people who suffer from loss of sleep. But since I already have 12 right here, that means this will be 6. Okay, if you do 6 plus 12, you get the 18. So that's a total of the 18 people who suffer from loss of sleep. So then you also want to do that for people who have rise blood pressure. So for rise blood pressure, you go like, how many people do we have that have rise blood pressure? That's 26. But if you look at it, you already have 12 in the middle. So you go like 12 Well, 26 minus 12. What's 26 minus 12? Well, that's 14. So if you do 12 plus 14, you get 26. So if you look at the question, we only want to find people that only suffer from one side effect. So we only want them to suffer purely on loss of sleep or purely on a rise of blood pressure. But we don't want people who suffer from both of these disease, or sorry, both of these side effects. So that means we don't want the 12. We only want the 6 and the 14. So if you do 6 plus 14, you get 20 over 100, and that's 20%. And that's it for 31. Right. Any question for 31? All right, so let's do 34. So let me go to the notes. Okay, so let's go here. All right, so let's go here to the announcement. All right, so some of you have been asking me questions that I, like Ari said, it's not going to be on the test. So if you just go right here for the announcement, these are the questions that are not going to be on the test. So 34, 35, 43, 44, 45 are not going to be on the test. So don't worry about those. Those are not going to be on the test. Plus the other one that I tell you not to worry about. So just look at the announcement. The announcement will tell you which question don't have to worry about for the final. All right. Any other question in regard to the practice exam? All right, so let's do 36. So if you look at 36, it says economists want to estimate the mean income for the first year of work for college graduate who had had the profound wisdom to take a statistics course. How many such income must be found if we want to be 95% confident that the sample mean is within 500 of the true population mean? Assume that the previous study have revealed that for such income, sigma is equal to 6,250. Okay, so for this one, if you look at it, so let me, so here you go, 36. So right now you're gonna write down the information that they gave us. So they want a 95% confidence level. So we'll say confidence level is 95%. If you look at the sample mean is within 500, so within 500 mean margin of error is equal to 500. And then lastly, if you look at it, it says assume that the previous study have revealed that for such an income, sigma is equal to 6,250. Sigma is equal to 6,250. Or you know what? Sorry, 36, we actually never got to 36 because this is actually something past chapter 16. So 36, just ignore it. It's not going to be on the test. So let's see. All right, so 41. So let's do 41, 41, 41, 41. All right. Let's do 41. If you look at 41, it says a consumer agency that proposed that lawyer rate are too high wanted to estimate the mean hourly rate for all lawyer in New York City. So it says a sample of 70 lawyers taken from New York City shows that the mean hourly rate charged by them is $223. So far they gave me the sample size. Sample size is 70. If you look at it, they also gave me the sample mean. So the sample mean is X bar, which is 223. And then they tell me the standard deviation of $55. So they tell me S is equal to $55. So if you look at 41, 41 say construct a 99 and 90% confidence interval for the mean hourly rate. So we want to do a 99% confidence interval, but we also want to do a 90% confidence interval. All right, so let me go ahead and transfer over to my notes. So right here, I got n is equal to 70, sample mean is equal to 223, sample standard deviation of 55. So on our calculator, what we're gonna do, we're gonna just use the t interval. So we're gonna go ahead and just use a t interval, or let me see. Correction. So we're gonna just do the z interval for this problem. So on ClassCalc, we're gonna go over and we're gonna do the z interval. So let me go ahead and transfer over to ClassCalc. So there you go, ClassCalc. We'll delete this. We'll go right here. So all you have to do is go to the stats button, go to test, and go to z interval. So you enter standard deviation, which is 55. You enter X bar, where X bar is equal to 223. You enter N, where N is 70. And after you enter confidence level, which is 99%. Oh, sorry, 0.99. So if you look at it for 99, you get 206.07 all the way to 239.93. And that's it for the 99%. Then you also want to do that for 90%. So for 90%, it'll be equal to 212.19, and you get 233.81. And we're done with that problem. Any question in regard to how I did that problem? Cool. All right, so that's how you write the answer. So if you look at it for 99%, is this. For 90%, the answer will be this. And that's it for that last round. Any question for the last round? So TI-84. All right, if you're doing this on the TI-84, let me show you. So on the TI-84, what you want to do, you want to hit the stats button. You go here where it says test. And if you look at number 7, it says Z interval. So we go all the way down to Z interval. So make sure it has to be on the stats option. So if you look at it for sigma, I have 55 already. So just leave it at 55. For the sample mean is 223. For N is 70. And then for confidence level, just do 99%, go to calculate, and you get the first answer. So you get 206.07 all the way to 239.93. So that's how you get it for 99%. If you want to get it for 90%, go to stats, go to test, go to Z interval, and just change it from 99% all the way to 90%. And then you get 212.19 to 233.81. And that's it. So that's how you deal with the TI-84. Yeah, you're welcome. Any other questions? All right, 42. So let's go to 42. All right, so let's do the margin of error. So for this one, what we want to do, we want to find the margin of error. So to find the margin of error, the formula for margin of error is this as follows. E is equal to Z alpha divided by 2 multiply by S all divided by square root of N. So if you look at it, I have S, which is 55. I have square root of N, which is square root of 70. The only thing I have to find is what my Z value is. So I'm first going to do this for 99%. So for 99%, you're going to use the T table that I gave you. So if you look right here, if you look right here, it says Z value right here. So since it says the Z value right there, what we actually want to go ahead and do is look for confidence level 99%. So here's confidence level 99%. And if you look right above it, it says 2.576. So 2.576. So you say 2.576. So then just go ahead and multiply those two out. So you get 2.576 multiplied by 55 divided by square root of 70. And you get 16.93. So that's for 99%. So say we're doing this for 90%. So if I'm doing for 90%, the only thing that's gonna change is my Z value. So I'm gonna go back. I'm gonna go here for T-table, and we're gonna look for 90%. So for 90% is 1.645. So 1.645, 1.645. They put 1.645. So just go ahead and multiply that out. So you do 1.645 multiplied by 55 divided by square root of 70. And you get 10.81. And that's it for that problem. So those are your margin of error. Any other question you want to go over? All right, so let's go over 46. Well, pretty much is the same thing. So let's go over 47. So if you look at 47, you have a bivariant data set. So bivariant data set just means you have two data sets. So you have your X data set and you have your Y data set. So pretty much what you want to go ahead and do, you want to determine the regression equation. So for this one, you could actually just do this in your TI-80. Well, you could do that with the TI-84, but we could also just do this with ClassCalc. So I'm going to go ahead and do this in ClassCalc. So first thing you want to do is enter all of your X value. So to enter all of your X value, so if you actually hit the plus button, and if you hit table, this should actually come out. So I'm gonna enter all of my X value. So we'll say 0.2, 0.3, 0.4, 0.5, and let's see what else, 0.6, 0.8, and then 1.1. Right. So those are your X value. Now we're gonna enter your Y value. So 20, 30, 22. So we'll say 20, 30, 22. And then once again, it's 30. And then if you look at it, it's 38, 23. 38, 23, and again 30. So if you actually press this magnifying glass, it should give you a scatter plot. So here's your scatter plot. All right, so up next, what we're gonna go ahead and do, we're gonna go ahead and you tell the calculator what to do with this information that I just entered. So for this one, we'll go right here. Let me get my sidebar back up. So we'll go to stats, we'll go to advanced, and you go right here where it says then reg. So right now what it's doing is expecting you to enter data. But if you look at it, I already entered the data set right here. So all you have to do is reference the data set. So if you look at it, this data set is called X1. This data set is called Y1. So to tell it to look at X1, you put X1. To tell it to look at Y1, you put Y1. Cool, and we're done. So if you look at it, here goes the Y value. So here goes the equation. So the equation is Y is equal to 6.01 x plus 24.22. If you look at it, it also gives me the answer for r. R is 0.2976. And that's it. And that's your answer. Any questions so far on 47? Wait. All right. Any other question? Yeah, so this is the last class. So after this, no more class. So the final is gonna be up on Monday, and you're gonna have all the way till Friday to do the final. So it's gonna be Monday all the way to Friday. But once you start the final, you only have 2 hours to complete the final. So 16 questions. Any other question? Your grade for test number 3 should already be up. I already graded it. Okay. Any other questions? All right, cool. So there's no any further question. Pretty much you get close out the meeting. So for this one, you kind of know for next week is essentially his final week. So just do the final whenever you can, and that'll be it. I am going to be holding any office hour in case you do want to kind of just pop in and ask questions. So the office hour is going to be 10 to 12 p.m. on Tuesdays and Thursday. And that's pretty much it. So if you do have any other further question, you could go to my office hour on Tuesday or Thursday from 10 to 12 p.m. All right, but if there's no further question, I'm going to close out the meeting and good luck on the final. Bye.